We're just going to give it a few more seconds here to make sure everybody has a chance to get on board. Wait for that clock to hit the magic hour. We had over 140 people register for this webinar, so we want to give them a few minutes to get on board. Let's get started here. I'm Katie Wolf, and I'm the Executive Director of the Watershed Council, and I will be facilitating today's speaker series. We have more than 140 registrants today, and so when we get to the Q&A, we may have to take some of those questions offline because Carolyn has a tight deadline. So just to give you a little bit of background, our Icebreaker series has been going on for several years, and this is the second in the series, and we're hosting them every other Wednesday through April. So a little background about the Watershed Council. If you're not familiar with us, we're a nonprofit, we're a membership-based organization with 43 years of history, protecting and improving water resources for Northern Michigan. We protect, restore, and enhance our lakes, streams, wetlands, and groundwater through respected advocacy, innovative education, technically sound water monitoring, and thorough research. And then additionally, restoration actions. We achieve our mission by empowering others, and we believe in the capacity to make a positive difference. Our service area, we work locally in watersheds within Antrim, Charlevoix, Sheboygan, and Emmett counties, as well as regionally and throughout the Great Lakes Basin to achieve our goals. So some of those watersheds tap into other counties as well, and so we do extend a little bit beyond that area. The Watershed Council speaks for our members, including full-time and seasonal residents, lake associations, and businesses, and then we work to maintain the environmental integrity and economic aesthetic values of the Great Lakes, inland lakes, rivers and streams, wetlands, and groundwater. So just a little bit of housekeeping today. We will have all attendees muted during the program, just to avoid any background noises. If you have a question, we're using the Q&A function, and we will answer those questions primarily afterwards, unless there's something that's really timely that Carolyn is currently discussing. She has a tight 1 o'clock departure time. So if we run tight on questions, as I mentioned earlier, we'll note those questions in the Q&A box and get back with you individually. Lastly, this webinar is being recorded, and we will have it available the next day on our website at watershedcouncil.org/past events. We'll also post it on Facebook. And so throughout the presentation, you are going to see a few polls that we're going to take, and so just be aware of that. And next, I'm thrilled to introduce our speaker, Carolyn Foley. We are particularly thankful to her because we had Kennedy Bucci was originally scheduled and had to cancel, and Carolyn was gracious enough to step up and put together an excellent presentation for you. Carolyn is the research coordinator for Illinois-Indiana Sea Grant program at Purdue University. She has a Bachelor of Science in Biology from the University of Windsor, Ontario, and her master's in entomology from Purdue University. She's been involved in a collaborative effort to study impacts of plastic litter distribution throughout the Great Lakes watershed, the integration of plastics into Great Lakes food webs, and innovations to prevent plastic litter from entering our freshwater systems. So thank you, Carolyn, so much for joining us today, and I will turn this presentation over to you now. Carolyn, you're muted.
I apologize. Thanks to the tip of the Mitt Watershed Council for having me here today. And I appreciate the opportunity to share some of my research and some of the, not just my research, the research of many, many great people who are working around the Great Lakes. So can you, here, 1 second, sorry. Can you see my slides okay? Try to launch it again.
Your slides.
Okie doke. So what I'm going to talk about today is a variety of research that is happening around the Great Lakes Basin. First, just a reflection for a second. If you could think just to yourself, what's the most common thing that you put into your trash at home? Do you separate out your recyclables? And how much trash in pounds do you think that you generate each day? And for reference, a gallon of milk is about 8.6 pounds of trash. And so part of what we're going to try to do through this talk is talk about the sources of plastic and then what we can do about them and kind of what's happening in between. The US EPA pulled together an analysis for 2018 that estimated that on the whole, the United States generated 4.9 pounds of municipal solid waste per person per day in 2018. And so here we have a graph. It has over time, the blue line with the triangles is the total municipal solid waste generation. And then the orange line is the per capita generation. As you can see, 2018, the most recent year for which they did this analysis, are both quite high. And the overall estimate of municipal solid waste generated in 2018 was a total of 2.94 million tons. Of this 2.94 million tons, 12.2% of that was plastic. So that's this yellow piece of the pie right here. This is again from the US EPA report. And that 12.2% equates to 35.7 million tons of plastic that was generated in the United States just in 2018. What happens to this plastic? It may be landfilled, which is the gray bar here, recycled, which is the darker blue, or used in combustion with energy recovery, or also known as waste to energy. So again, this is a graph from the US EPA. Along the X, we have years. Along the Y, we have the tons of plastic. And then the colors are kind of how much is going to different things. So you can see in 2018, the vast majority was going to the landfill. There was some that was going to this waste to energy, and then there was a portion that was being recycled. So there have been a number of estimates done in the scientific literature, and some of the kind of staggering statistics, they think approximately 92% of the plastic that was ever produced still exists somewhere in some form. So that's worldwide, ever produced, still exists somewhere in some form. And then approximately 20 million tons of the plastic produced each year globally enters aquatic habitats, which is kind of like a shocking statistic. Plastic litter in aquatic environments can have several fates. It can accumulate either in, gyres along with currents if it's floating up in the water column. It can accumulate down at the bottom at the sediment water interface or at the substrate. It can be ingested by wildlife. There's a lot of examples of images from the news where you see this. or it could break down or decompose. And you're probably potentially also familiar with this very image of the Five Gyres Institute. Those are microplastics and microbeads compared to a penny. So today we're talking about microplastics. So microplastics are plastic particles that are less than 5 millimeters in one dimension. They are quite small. 5 millimeters is maybe like the size of a little lentil, if you eat lentils, or if you stacked like 2 pennies on top of each other, it's smaller than that in one dimension. There are primary and secondary sources of microplastics. Primary means like these are the plastic particles, they're produced, they go straight into the environment. These include production pellets or nurdles. This is actually a huge source of them. These are things that go and get pressed into molds and used to create bigger plastic components of everything that we use in life. Another primary source is microbeads, which could potentially be found as like exfoliants in skin products or things like that. Sorry, wrong way. And then there's secondary sources of microplastic, which is like, these don't go into the environment as microplastic, but once they're out there, these are things like fragments, foam, and films. So things that might come off of a plastic bottle as there's action pulling it apart, or the kind of plastic that goes over your food, things like that, even plastic bags as well. And then another main source of secondary microplastics is synthetic fibers, which are kind of long, spindly. So these may not be, the synthetic fibers, they may be longer than 5 millimeters in one dimension, but they're also super skinny. So this is an example of, so if you, Petri dish up here, it's probably about, I don't know, probably about 4 inches across. And so this is zoomed in. This was a water, I think this was a water sample that was filtered. And so you can see, here's an example of what a fragment microplastic particle looks like. This is an example of a foam. This is an example of a fiber. This is an example of a pellet. But there are many different morphologies and colors and different things like that of plastic materials out in the environment. So some main sources of microplastic include domestic wastewater. So fibers from clothing, when you're washing them in your washing machine, they may flick off and go out with the wastewater. There's also there's incomplete treatment removal. Wastewater treatment plants are actually pretty good at filtering out microplastics. So between 75 and 99% may be removed at the source before they go out into the waterways. But the sheer number of microplastics that are being produced means that even if just 1% gets out, that's still like millions and millions of microplastic particles that are going out into waterways. Other sources of microplastics include personal care products, so toothpaste, like we said before, kind of skin stuff, terrestrial runoff, and river movement to downstream ecosystems. So if it happens to, same as, non-point source pollution like nitrogen and stuff like that, microplastics can be delivered to waterways the exact same way, and then break down from larger litter. For example, if there's something out floating in the middle of the lake and the sun breaks it down and the wave action breaks it down and little flecks start to come off. Over time, there have been increasing studies in marine ecosystems at the same time as plastic industry growth. So I'm going to go through this timeline relatively quickly, but just to show some key things. So 1973, marine pollution was found to cause considerable harm. So that was, more than 50 years ago. In 1982, research first demonstrated the detrimental effects of plastic to marine birds. 1987, major inputs to ocean debris were found to be land-based. 1999, there was research that found that plastic outweighs plankton 6 to 1. And so as all this stuff is happening in the marine and learning about the plastics, at the same time, plastic production is kind of going up. Plastic use is becoming more common at the same time. Then we have in 2010, fish were found to be eating plastic in the Northern Pacific Gyre. And then in 2016, the United Nations estimated that there were 5.25 trillion pieces of oceanic macro and microplastics. And throughout this talk, I'm going to talk mostly about the effects of microplastics, but particularly when thinking about solutions, I'll hop back and forth between macro and micro because macroplastics are such a big source of microplastics in the environment that reducing the amount of macroplastic would also reduce the amount of microplastic. So, okay, sorry. So I'll go back here. So microplastic is pervasive and persistent in aquatic ecosystems worldwide. This is a study from 2021 where what they did was they tried to take all of the microplastic sampling that they could find, all of the data they could find from all over the world, make it comparable to each other, and then develop this scale where they're calculating the number of pieces per meters cubed. And they did a variety of analyses, but this was kind of the most basic one. So this may be a little bit hard to see, but the point is that the deeper red, the deeper purple, darker purple is higher amounts of microplastic. And so you can see like in Europe, over in Japan, and these correlate with where studies have been done. It doesn't mean there's no microplastic here. This is just where the studies have been done, where the data they could find was available. But I do want to point out the Great Lakes are over here. And it's very blurry because zooming in, I could not make it resolved. But if you know, there's quite a lot of purple here, like dark, dark purple around the Great Lakes. So we do seem to have among the highest numbers of microplastic particles per, per volume in the world. So microplastic is present in Great Lakes waters. This is a study from 2013 where they did samples of surface waters. A bigger circle means a bigger number of microplastics per kilometer squared. So it's a different unit area. But as you can see, there's microplastics that were found throughout the Great Lakes. This is from a study that is not, so this one on the left was, they actually went out and grabbed samples and looked at the plastic particles. The one on the right was a modeling study. So there's a lot of really great data where people have looked at currents. And because you all are thinking about the straits, that's one of the most dynamic places in all of the Great Lakes. So they used the models of water transport throughout the Great Lakes, and they sort of correlated it with population. They said, okay, if we were to estimate that, you know, this much plastic was released at this location and this much plastic was released here, and then we run the model, what do we see in the open water? And so here, yellow is higher, blue is lower, and kind of the gradient in between. But again, you can see that they estimated that the average particle density in open water is reasonably high in the more populated areas in southern Lake Michigan, along Lake Erie, and then Lake Ontario. Lake Ontario will come up again later because we also have that, you know, flow is going and everything winds up in Lake Ontario before it goes out to the ocean. In 2013, there was a survey of microplastics in surface waters in Lake Michigan, led by Sam Mason, who was at the State University of New York at Fredonia, I believe is now at Penn State University. And I want to take a moment to acknowledge we have a lot of microplastic rock stars in the Great Lakes Basin. So Sam Mason is one, Chelsea Rockman, which Kennedy Bucci is from the Rockman Lab. They are at the University of Toronto. Patricia Corcoran at Western Ontario University in Southern Ontario, and then some researchers at Loyola University. So like John Kelly and Tim Holeen. So we are really lucky in the Great Lakes to have these microplastics rock stars who are helping us understand where things are and where they're going. So I'm going to share some of their stuff, but I wanted to make sure to acknowledge them. So this 2013 survey, here the triangles, bigger triangle means higher plastic abundance, and again it's count per kilometer squared. But again, as you can see, even up in the northern part of Lake Michigan, they found some pretty high numbers of microplastics. And this particular study was one of the first ones to highlight that microfibers are way more problematic, seemingly. Well, sorry, I shouldn't say they're way more problematic. They're far more present in lakes, in the Great Lakes, and then they didn't see fibers as much in marine ecosystems where the work was previously being done. So microplastics are also present in Great Lakes sediment. This is a study out of Patricia Corcoran's lab at Western Ontario. We have a map of Lake Huron here. A bigger yellow dot means higher abundance, but they're looking specifically at the sediment. So we're at the bottom of the lake now. And this is overlaid with bathymetry of the lake. So a darker blue color is deeper. So you can see that some of the bigger circles are in places that are deeper. So that sort of makes sense that the microplastics may be kind of settling down into the deeper portions as they're moving around and things like that. But they are absolutely present. I apologize that this is a little bit tricky to see, but this is the breakdown of the type of plastic, like shape in terms of fiber is this darker blue, fragment is the lighter blue, and then film and bead are lower. But the vast majority, the point of me showing you this is that the vast majority that are being found again are fibers and fragments, even in Lake Huron sediments too, which is a little bit different from some other locations in the world. Microplastics have also been found in tributaries. So the USGS and again, Sam Mason, so it was Austin Baldwin at the USGS and Sam Mason and others. In 2016, they published a study where they had visited a bunch of tributaries. These are the watersheds. They had a variety of land covers within those watersheds. And what they found, and this is a little bit busy, but the point here again is they're looking at different types of plastic, the 5 different types here. They were looking at, higher along the axis here is a higher concentration. And then along the x-axis, they have a variety of combinations of like urban or like the land cover and the flow conditions in the tributary. And something again that I find really interesting is the fibers and lines are kind of, it doesn't really matter where you are, they're among the highest concentrations that are found. Otherwise, urban is slightly higher, but these error bars, it's pretty variable. So we know microplastics are everywhere, and this has caused a lot of discussion in the scientific community. So there was this article that came out in Nature magazine in May of 2021, microplastics are everywhere, but are they harmful? There have been things like titles like microplastics, much ado about nothing, and things like that, because plastic is a thing that can really engage the public because everybody uses plastic, like versus some other chemicals where, it's a bunch of acronyms that you don't necessarily understand. Like I can pick up plastic right now that I use in every day, so I can understand that and I can connect to it. So it engages the public in a way. And people have been doing a massive effort to understand, are they harmful? So first, we're going to talk about in the Great Lakes, some of the studies that have been done looking at organisms that live here. So in 2018, there was a study in Scientific Reports by a team from Loyola University, Chicago. They sampled 3 different tributaries, the Milwaukee River, the Muskegon River, and the St. Joseph River. And they looked at both water, microplastics in the water and microplastics in fish that were sampled. And so what they found when they looked at, kind of different sites, so along the X here, we have 3 different sites, Muskegon, Milwaukee, and St. Joseph. And then along the Y on the left, we have the mean microplastic concentration, the number of microplastic particles per fish. And on the right, we have the number of microplastic particles per liter of water in the same locations. And so the water, the St. Joseph River is much, much higher than Milwaukee and Muskegon. So the A and B talks about statistical significance. So Muskegon and St. Joseph are statistically significantly different. Milwaukee is not statistically different from either one of those. But this gradient is not mimicked in the fish, right? So Muskegon fish, there's no significant difference. They all have relative, and we will point out, that the ranges are different here because you're looking at water versus fish and you're measuring slightly different things. So the team looked at something else. They started to look at the species. And so along the X here, this is from the same study, along the X, we have different species of fish that they looked at, and they just looked in their guts and looked to see what microplastic particles were there. Along the Y, they have the number of microplastic particles per fish. And so these are grouped by the way that they eat. So they are kind of eat organisms that are down toward the bottom of the water column. The gray is omnivores, they'll eat anything. And black is detrivores, they tend to eat more like plants and stuff like that. And the team called out specifically round gobies and gizzard shad. So this is the round goby. It's an invasive fish throughout the world, but also in the Great Lakes. And so it's a voracious feeder. It'll just like suck up everything along the bottom. And so they thought that maybe it had higher concentrations of microplastic just because it was eating all of the things. And maybe those organisms had microplastics in them too. And so they were getting into the gobies. And they found a little bit of a relationship between like bigger gobies had more microplastics, but that's not always, that relationship doesn't always hold. And then gizzard shad was the only fish that they found that had no microplastics. And they attributed that to that they eat more algae and stuff like that. And so, but basically they said, you know, there are differences and it's probably a little bit more than just kind of, you know, where they happen to be. So there was another study, this is out of Kelsey Rockman's lab at the University of Toronto and the Ontario Ministry of Natural Resources. They looked at fish from Lake Superior and Lake Ontario. And this graph is a little bit busier. So along the top here, these are species along the X again, and then the number of anthropogenic particles per fish. They said, like, sometimes you'll see anthropogenic particles, sometimes you'll see microplastic, because typically in a study, they will go and they will say, okay, like, they'll count what they think is microplastic, they'll do some tests, and then a subsample they'll take and do additional tests to try to figure out like what type of plastic it is or things like that. So, but then they may identify in that subsample that like cellulose is a really big one that is not plastic, but it probably did come from fabrics and things like that. So that's when you see anthropogenic particles, typically it's because they couldn't confirm that, you know, everything was a microplastic or a large portion was also cellulose, but the mechanism is kind of similar. So they looked at a couple of different locations in Lake Ontario, Hamilton Harbor, Humber Bay, and Toronto Harbor. There's a lot of population around those. And then Lake Superior, they looked at Mountain Bay, Nipigon Bay, and Thunder Bay. And these were fish that were collected here. They looked at what was in their guts again. And you'll see there's a lot of variety. First off, you know, Lake Superior, the numbers of anthropogenic particles per fish are lower. It's, you know, the maximum of 150 versus 500, but it's still not zero, right? And so lake trout in particular, I think this is lake trout, and these are the whitefish, are kind of on the like comparable to some of the ones that were found in Lake Ontario. Down here, they're looking again at kind of where they happen to live. And so whether they live toward the bottom or up in the water column, that changes the amount of microplastic that they're finding. One really interesting thing about this particular study, all of the fish they sampled were contaminated with anthropogenic particles, and the range was from 2 to 915 particles per fish. And I believe at the time that this was published, 915 anthropogenic particles per fish was among the highest, if not the highest amount that was ever recorded in studies around the world. So again, Great Lakes fish may be being exposed differently than organisms and Great Lakes organisms in general may have different exposure levels than other places or different. Also, I am an aquatic person, so I'm actually an invertebrate person. At one point I realized I either had to study fish or birds because lots of people don't think that unless I'm trying to control insects, then I'm okay. So I did want to mention, I don't know as much about the birds, but there was a recent study in 2022 out of Loyola University and Auburn University down in Alabama was a collaborator, and they looked at some birds, migratory birds down in Lake Michigan, and then some nestlings. So over here, like again, along the Y, we have number of microplastics per bird. And I think the biggest thing is that it's not zero. And it's highly variable depending on the species. So these are a variety of different birds. And then I think this one was nestlings that they were looking at, tree swallows. And so even the nestlings had pretty high amounts of microplastic in them. Or sorry, not necessarily pretty high, but they had microplastics in them. So we know ingestion is happening worldwide, but also in the Great Lakes, we have evidence of that. But in terms of what is the risk to an organism's health, that's a little bit of an open question. So, right. So there's a lot of lab studies where people have looked at the ecological impacts, and they have seen that, you know, in the lab, filter feeders, zooplankton, and fish will eat various things. The prey can transfer up to a predator through the food web. So like microplastics can transfer through the food web. They've seen that in lab studies. And they've also seen effects where they don't reproduce as well, they don't produce as many eggs, they don't grow as well, they don't survive as well if they're exposed to microplastics or if they ingest microplastics. There's also some evidence that different types of microplastics host different microbial communities, which can then have ramifications throughout the food web. But a lot of this work was done in the lab. There's also evidence that there are toxicological impacts where, you know, you might leach chemicals like BPA, which is an endocrine disruptor that can sort of mess things up for a variety of organisms. And they can absorb chemicals. So the hydrophobic surfaces, so the surfaces of the plastic, can grab onto POPs or persistent organic pollutants, which those are chemicals that, so when people think, okay, are microplastics really a problem? POPs, people, they know they're a problem. They know they cause issues and things like that. Research on marine plastic has demonstrated that the risk to marine animals differs by plastic type. So there's just so many different possibilities here. So in Great Lakes, there was a really cool study out of Grand Valley State University and supported by the Illinois Sustainable Technology Center, where in Muskegon Lake, they put out these arrays of microplastic particles where they put them out in the lake, and then they tried to look to see, okay, if we put them in realistic conditions, this is a real lake, there's going to be real stuff that grows on them, will persistent organic pollutants or heavy metals or pesticides, will those kind of, like, what happens in the field? We know maybe it can happen in the lab, but what happens in the field? I think this study is just super cool. Okay, so this is a picture of these are the microplastic particles before they went out into that array, into those little containers. And this is after they'd been deployed for 3 months in Muskegon Lake. So they have stuff that's growing on them. And then the team analyzed kind of like, okay, what might they have, like, can other things attach on along with the, like, the biota, the microbes, the biofilms that are growing there. So looking specifically at PFAS, and there is, if anyone's interested in the original papers that I'm referencing here, I'm happy to share the links for those. But this one is, and a lot of them are open access too. So you should be able to look at them yourself if you want to. This paper that came out looking specifically at PFAS found, somewhat alarmingly, that the absorption of PFAS was much greater in the field incubated plastics, so the ones that had been out in Muskegon Lake, than what was observed in the laboratory with plastic and water alone. So that is concerning, that the microplastics may be grabbing on to PFAS. And then potentially that could be a delivery system of something that is definitely of a concern to organism and human health. The other chemicals that they looked at were polyaromatic hydrocarbons, or PAHs, polychlorinated biphenyls, PCBs, organic pesticides, and some metals and microbes. And the findings in that study, which has also been published within the past few years here, they said their results indicate that persistent organic pollutants are capable of accumulating on the microplastics, but the concentrations generally were low. So they said that feeding trials would be needed to determine if the environmentally realistic concentrations of pollutants, so the stuff that's attaching at the levels that it really does attach at, will that result in impacts to aquatic organisms like fish, invertebrates, birds, or, you know, ultimately humans. And so this brings up a really important point of environmentally realistic or environmentally relevant concentration. So a lot of the lab studies in the beginning used concentrations, and you may have heard this already, but they use concentrations that are far higher than what's actually present in the environment. And that sort of made sense at the time, right? You're like, oh my goodness, okay, is microplastics going to be a problem? Let's crank it up and see, at what range is it, safe. So there has been a push in the scientific literature for using environmentally relevant concentrations in terms of when you're doing studies, making sure that you're including at least one level that fits with what's actually out in the environment, so you can get a better sense of what's going on. So, so that's a big thing that you'll see over time. And when you see studies in the news, a lot, like sometimes the results that are being reported are based on these really, really high concentrations. And so that kind of, I'm not saying take it with it's not, ignore the things, but it's stop and think, okay, is that what we're actually being exposed to right now? At the same time, it doesn't seem like plastic concentrations are going to go down. And so now we're going to talk a little bit more about what might happen, as plastic concentrations go up. So the summary that we have is that microplastics are present in Great Lakes waters, sediments, and organisms. Fibers and fragments seem to be the most abundant shapes. There's also a lot about types. I saw one talk where they had figured out that it was like, okay, this is Michigan, so I can say this because everybody knows what Meyer is. They figured out that like one piece of plastic was from like the blue dot on the Meyer bag, which I just thought was completely wild that they could trace it back like that, like it's the blue dot on the Meyer bag. So so there's a whole bunch of other factors that would be, you can try and figure things out, but it's also overwhelming how much information there is. We also know that some other contaminants can absorb onto microplastics, but the question remains, like, are they a problem? And it sort of depends on how you define problem. So in excuse me for a second. In 2018, I led a meta-analysis that looked at the effects of exposure to microplastics on fish and aquatic invertebrates. And 2018, we were using things that had been published in 2016, and 2017 and earlier. So if we were to redo this meta-analysis right now, I actually really want to redo this meta-analysis right now because there would be a lot more data for us to look at. But what we did was we looked at 43 published studies, and we were trying to ask, these were all lab studies because we wanted to have a control where they were not exposed to microplastics, and we wanted to compare that to something where they were exposed to microplastics. And so the questions we were asking was, for aquatic organisms, what is the impact of exposure to microplastics on their feeding or consumption, their growth, their reproduction, and their survival? And these studies measured a huge variety of endpoints, things like, growth, like sometimes they were measuring length, sometimes they were measuring weight, sometimes head widths, different things like that. Reproduction, sometimes it was how many of their clutch survived. Sometimes it was how many eggs did they produce. And the beauty of the meta-analysis is you create these kind of standards within a study, and then you summarize them more broadly. And so I'm just going to check to make sure that, okay. Thanks. Thank you, Kala. Okay. And so what we found looking over these studies was that the effect, and like broadly, the effect varied with the taxonomic group. So based on what we were able to find in the literature at the time, we looked at a variety of different taxa. Zooplankton, echinoderms are like sea stars or sea cucumbers, mollusks, macroinvertebrates, it was often worms and things like that. And then larval and juvenile fish and adult fish. At the time, there were not really that many studies. So what we basically found was that the majority of the effects were seen on zooplankton. And then it really reflected in this table, but like when we collapsed everything together, we saw that there were a number of effects on, like negative effects on consumption. There were no positive effects. And there were a lot of kind of ambiguous effects at the time. And I got interviewed about that. And I remember them saying, so like, what do you say? Do you say that plastics are fine? And I said, I don't think I'm ready to say that. I think we just don't know right now. And again, like, I think if we did this again now, it would be really, really, I think it would be fun. So putting the results together from that meta-analysis, seeing that lower food web tends to be most affected, and others have found these types of things too. And overall, the greatest negative effects were related to feeding in aquatic organisms. And unfortunately, none of the studies that we had were from the Great Lakes at the time. So unfortunately, I can't point you to that. But if you think about Lake Michigan food web, even if the upper levels are not being as negatively impacted by microplastics, if the lower levels are impacted, then that can cause pretty big ramifications throughout the food web. And also, if you think about the many, many other stressors acting on Great Lakes organisms, which include things like aquatic invasions, habitat loss, a changing climate, and other pollutants, if you add in little plastic particles are filling your gut. So like one of the studies that we looked at, it was kind of looking at the clearance rates, where they would go around, they had worms crawling around, and then they would count like how many of their kind of fecal packets were there. And when they were exposed to microplastics, there were fewer. So it suggests that things were passing more slowly. So if you had little plastic particles filling your gut, and you're also stressed out by a bunch of other things, in my mind, that suggests that it's not going to be a helpful thing. It may just add more stress, particularly in places like Lake Michigan and Lake Huron, where one of the issues is that there's not a whole lot out there for things to eat necessarily, right? Because Dreissena mussels have put, Seagra and quagga mussels have pulled things down to the bottom. So heading up to humans and thinking about the impacts to humans, again, you may have seen many of these in the news, but microplastics have been found in sea, lake, rock, and well salt, chicken gizzards, honey, beer, tea bags, as I'm drinking my tea, drinking water, both bottled and tap water, seafood, and shellfish. Humans consume, there are estimates that they consume up to 52,000 microplastic particles per year as baseline. Inhalation, because there are microplastics in the atmosphere as well, adds 69,000 particles per year. Consuming only bottled water adds an additional 90,000 particle per year, but if you were drinking tap water, it adds an additional 4,000. And polypropylene bottles release up to 16,200,000 particles per liter, which is, again, are pretty staggering numbers. To our knowledge, no published study has directly examined the effects of micro and nanoplastic on people, but microplastics have been found in all regions of the human lungs where fibers were most abundant and inhalation is an important route of exposure, and then in the human bloodstream. But that study, they looked at 22 people, but they did demonstrate as a proof of concept that plastic nanoparticles are bioavailable for uptake into the human bloodstream. And then larger microplastics are most likely to have effects due to their chemical toxicity and other things that have been added to them. So now we get in the last few minutes to what can we do? And so I'm going to go back to something that I really wish that I could meet the person who mentioned this to us in like 3rd grade or whatever, that it stuck with me that reduce, reuse, and recycle are in that order for a reason. They said it at the time, and it has stuck with me for my whole life that they're in that order for a reason. So we can try to reduce our reliance on plastic and the amount of plastic entering the environment. Again, even macroplastics, because they are such a huge source of microplastics. We can reuse, and when possible, we can limit single-use plastics or change some behaviors to use, for example, like normalizing bringing your own containers to restaurants or things like that. And then keeping in mind that recycle is 3rd for a reason, because it still takes energy, and especially plastic recycling, we've heard in the news that it's maybe not effective or not as effective as we would hope it would be. It's important to note, like, changing things, it won't be easy. There's a question about, is this a corporate responsibility or should it be consumer driven? There's a big emphasis on personal responsibility, but many argue that corporations bear the lion's share of the blame for the plastic problem. And some research has found that only 20 firms produce over half of the world's plastic waste, and the leader there is ExxonMobil. And then based on global beach cleanup data, Coca-Cola is the #1 global top polluter. And then there are also some real challenges, particularly with respect to equity and accessibility. There may be reasons why someone needs to have a straw to drink out of when they are, like, because they can't consume liquids otherwise. There may be someone who walks to the grocery store and can't just throw a bag into their car and remember it that way. So if they get there and they've forgotten, there should be, some solutions in place to try to help them out, and maybe they can't afford a 25-cent plastic bag or things like that. So whenever people are thinking about stuff like that, I think it's a complicated issue. Similarly, there are benefits of plastic use, specifically related to food preservation and access to clean water. If the question is you drink bottled water that may be ingesting plastic, or you drink water that has heavy metals or bacteria that will make you sick, it makes a lot of sense to drink bottled water. And as fellow humans, we should be thinking about that. And then there are pressing issues. For example, COVID. There was research that found that PPE, or personal protective equipment, was an emerging source of plastic pollution in the Great Lakes. Disposable gloves and face masks and wipes, and the highest density was in grocery store parking lots, which again kind of probably makes sense. So some of the potential solutions, note that I'm not endorsing any of these, but they're just cool that they exist. There are fiber catching products for laundry that can prevent some release of microfibers into the wastewater. And again, this is Sarah Zach helped provided me with a bunch of these slides, so I'll say for her, no endorsements, but there's the Guppy Friend, which is a washing bag, the Coraball, which is something you throw into your washer, and then the Lint Lover, which you attach to the wall and it filters. And there is a study that found that the Lint Lover and the Coraball could significantly reduce the microfibers in the washing machine effluent. So it would at least be concentrated, and then you can figure out something else to do with it, which I'll touch a little bit on some of the exciting things that are happening in a minute. Engineering solutions in the field. This was so fun to think about. Okay, there's robots and vessels that are autonomous, that either travel around or are stationed. There's the Fred robot in San Diego and others available too. There's Mr. Trash Wheel in Baltimore. If you're on social media, I highly recommend checking out Mr. Trash Wheel for all sorts of reasons. And then there's a number that are being shared in the Great Lakes, and I will share this link again, or maybe Calla could share this link. The Great Lakes Plastic Cleanup has these just further discussion of the sea bin, the Lida trap, the pixie drone, the bee-bot, and the gutter bin. And some of these are being deployed throughout the Great Lakes already, and could potentially be used some more. But I have some links at the end too, and this is one that I would recommend people go check out. There's legislative solutions, of course, straw bans in Minnesota, plastic bag bans, Chicago bag tax, and it's a ban, but then in Indiana, Michigan, Minnesota, and Wisconsin, there's a ban on bans. And my understanding from chatting with Katie and Calla is that that happened really close to home for you all. And that was the students who had tried to bring it forward were kind of disappointed, which I feel for them. But then there's single-use plastic bans in New York with styrofoam, and Minnesota and Pennsylvania. But then there are also some local ones. However, again, when thinking about bans, ensuring that you're considering equity and accessibility and providing alternative products for people who truly need them seems a good thing to do. Because again, even if we're just reducing the amount of plastic, that's still good. It's still moving in the right direction. If you have other ideas, I'd be happy to have you all share them in the chat so that other people can learn from each other. I wanted to talk about a few more things, and then I wanted to leave a little bit of time. I see that there's stuff in the Q&A. I haven't read them yet, I'm sorry. But the Microbead Free Waters Act of 2015, it prohibits the so this is just a couple of other things to think about as you're considering what to do. The Microbead Free Waters Act prohibits the manufacturing, packaging, and distribution of rinse-off cosmetics containing plastic microbeads. So it's just things that like you would put on your face or in your hair and you would rinse down the drain. But even before this was being fully implemented, many manufacturers were voluntarily pulling microbeads from their products. And that's because consumers asked for it. They said, we don't want these in there. So I think, you know, I'm originally from Canada, but I've lived in the US for a number of years now. And I think in both places, I've really learned that, like, you know, voting with your dollars is something that all of us can do if we're able to. So another really exciting development in January 11th of 2022, the Department of Energy announced that they were investing $13.4 million to combat plastic waste and reduce emissions across the plastics industry. And this is really exciting. There was also marine debris issue call, a pretty big one issued through NOAA for some innovative technologies and things like that. And microplastics was included in that call. And so this suggests that, like, some of the things that they're funding here are like what to do after you've collected the microplastics. They're trying to find creative ways to upcycle them, or, you know, kind of use them in a more efficient way. Because even if you manage to collect everything in the sea bin, there's still the question. John Scott, who I mentioned earlier, every time he's on a talk, he says, okay, but what do you do with what you collected? And so there are people who are really smart people all around the US, all over the world, who are trying to innovate solutions there. And so speaking of energy, one last thing, I think this is my one last thing that I was going to talk about. So again, back to the beginning of plastics is energy. They have really strong chemical bonds, so there's strong potential. There was a study on bottled water on, like, the energy use in producing and distributing bottled water in 2009. And they actually found that the energy required to manufacture the bottles was as much or more than the energy required for transportation, depending on, like, transporting, you know, from all over the world, depending on where the bottled water was coming from, the energy just to produce the bottle was almost as much. So this is like, you know, in places where you're trying to figure out, like, energy issues, right? Because that's another issue facing us. If you look back at this graph from the beginning, this light part starts to look a little bit more like, it looks kind of cool, because what they're doing there is they're combusting down the plastic, and they're getting it, and so they're harvesting the energy from the combustion of the plastic, and then they're using it to power other things, which is a pretty cool, innovative solution. So then I went looking to see, like, okay, does that get rid of the microplastics? And I found this. Oh, sorry. One other thing. The US Department of Energy also supported a study where they estimated that the value of landfilled plastic waste in 2019 was enough to supply 5% of the power for the transportation sector, or 5.5% for the industrial sector. And so here, the bigger blue dots are more plastic waste landfill. Michigan, up around here, it's not super blue, but there's a little bit of blue. So there's potential there that they could be using to help the energy portfolio. However, I found this study, it's incineration, the terminator of plastics and microplastics. And if anybody had seen Terminator 2, that just, I don't know, it cracked me up pretty, you know, when I was looking at it. But it's also a really cool question. They looked to see, okay, is there anything left behind? And unfortunately, the answer is yes. There were still microplastics in the ash at the bottom. But if you combine that with some of the innovative ways to kind of upcycle the microplastic particles and stuff like that, then maybe we're getting closer to some good solutions. So there's some key links there that I encourage you all to visit. And I want to say thank you for your time, and thanks for the opportunity to share with you all. There are Sarah Zach at Illinois Indiana Sea Grant, Jill Bartolota at Ohio Sea Grant, and Brandon Schroeder, and then Mark Breederland at Michigan Sea Grant are all potentially good resources. So I'm going to stop sharing right now and thank everybody. So.
Oh, we do have quite a few questions here, so I'm going to try to get through some of these while you have a few more minutes left. Thank you so much, Carolyn. That was really informative, and I really appreciate it. Oh, the first question, can you speak more about how researchers sample for microplastics at the scale of the basin? Additionally, are there any theories of why synthetic fibers are higher in the Great Lakes compared to marine environments?
Sure. So I'll do the second one first. So some of what people thought was just population and the fact that, you know, Chicago, like if you look along the Great Lakes, there's a whole lot of the biggest cities in the US and in Canada as well. Like Toronto's the biggest city in Canada in the metropolitan Chicago area, but you have Detroit, Cleveland, Chicago. And so I don't know if it's been updated since then, but my most recent knowing was that it was just kind of like, there are more people, therefore more laundry is being done and things like that. The first question again was about how people sample at the watershed level. So there's a lot of, it depends on which matrix. So if you are sampling the like stream waters or things like that, the surface, it would be things like like a net, the same kind of way that you would capture like very small fish or zooplankton. You have to have a mesh size that is like small enough that the microplastics won't just go through. But sometimes people will grab like just a whole water sample and then they'll take it back to the lab and they'll filter it. So the sampling in the field would be just the water sample. Sediment, it's kind of similar. And then and the same with the organisms. One of the things that happens sometimes with water, but also definitely with sediments and organisms, what they tend to do before they analyze the microplastics is they use some kind of chemical to break down all of the organic stuff. So they'll put like, hydrogen peroxide or something like that to try to get rid of everything that isn't plastic. And then they'll try to look at the actual plastic particles. And then the actual grabbing and things like that, the things to be careful of are like the equipment that you're using and what you're storing it in. You don't want to accidentally introduce plastic into your sample from like whatever you're doing. So oftentimes you'll see like in studies that they have, like if they're using plastic bottles, they'll do one plastic bottle that doesn't have field water in it to get a sense of like how much of the plastic that we're seeing is coming from the bottle. Or they'll put filters around the lab. They'll wear like cotton coats and stuff like that. But then they will also, kind of double check that they're not introducing extra. I don't know, hopefully that answered your question a little bit. And then there's like different community efforts where people are, they go out all together and kind of grab things at the same time. So.
Okay, thank you. And so the next question, do we have any baseline data for the amount of microplastics in Little Traverse Bay? And can we determine how much it has increased locally?
Maybe. I would look increased over, it sort of depends. So I don't know the answer to that. I have many ideas for who you could ask though. So if you want to follow up, Katie.
Okay, I'll follow up on that one. Great.
Yeah.
Okay. This says, where can we find published data that was so small? I think it's when you had those four different plates, they referred to it out at once. So we'll follow up and track that down as well for you.
Yep. And a lot of the data are actually available and things like that. So it's pretty cool.
Another question, other than the Muskegon Lake study, are there other studies on microplastics in inland lakes? And are there concerns for microplastics in inland lakes?
Yes. Yes. Yeah. So this talk, like the truth is there are lots of studies of what microplastics are where all over. And I think, yes, they're, because they're so ubiquitous and they're coming from so many different places, yes, there are aquatic organisms everywhere are probably being exposed. Yes.
Can you address the effect of certain bacteria in digesting plastics?
That's a fun question. People are exploring that actively because that is like an active area of research where people are trying to see like, okay, could there be some kind of bioremediation where, so like some of the studies that I shared, they are analyzing like what microbes are colonizing it and then trying to see like, do they break down the plastic? Do they break down the other things that are on the plastic? I don't have great answers, but people are actively looking at that as a potential solution. And there probably is information out there. I just don't have it at the tip of my tongue.
Okay, we're down to the last two questions. So do microplastics make their way down to groundwater or does the soil filter it out?
Unfortunately, they can. There's a lot of people who are actually thinking about that, and microplastics and other contaminants too. This is another thing that's kind of tricky. We funded a study to look at, it's not microplastics, but looking at salt, to see, like, does green infrastructure, where the goal is to aim water down, is it accidentally also taking other stuff, or not accidentally, but is it taking other things down with it? And so they have found microplastics, and that's a link that I can share with you. I'm pretty sure there's a microplastics in some Great Lakes groundwater. So that is also a concern, especially when you're pulling, you're drinking water from various sources. Yeah.
So any evidence of microplastics in well water?
I don't know that one for sure, but probably the answer is, I mean, the truth is that and the other thing too is they're everywhere. I said microfibers, they think they're higher because of population, but the truth is that even in super remote areas, they find microplastics. They're everywhere, which is, for me, the motivation to try to stop what's going out there.
So last question, are biodegradable plastic bags really helpful? Are compostable bags different or better?
I don't know that I'm the best person to answer that question. I think you should invite a more of a chemist to come and answer that question. But I will say, I wonder that too. And I stop and think, if you don't have the fancy kind of system to break down some of those food containers or things like that, is it really, and I tell myself in my head that it's probably still going to break down faster than plastic would. But that's also why I'm the weirdo who pulls out my containers when if I go to a restaurant. So yeah.
Thank you. And so there's lots of thank yous, Carolyn, for the great presentation and for the work that you do. So thank you so much. There's one note on here that someone shared that University of Michigan has an exhibit and puppet show performance in Ann Arbor called The Plastic Bag Store, highlighting the crisis of plastics. And she gives a link for that. So we'll share that link as well. So, and lots of kudos to your presentation. I really appreciate having you. And, I feel like I had spent a lot of time on microplastics, having worked for NOAA, but I learned a lot from listening to you. So thank you so much.
Well, thank you for the opportunity, and thank you all too for being here. Really appreciate it. So, okay.
And then just a few things I want to make sure. One, in addition to being so appreciative, I do want to make sure that you're aware of upcoming speaker series. We have our next one coming February 8th, and we have a great speaker, so check it out on our website. We'd love to have you join us. And if you support the type of activities we're doing here at the Watershed Council and this Icebreaker series, we'd encourage you, if you're not already a member, to join the Watershed Council and help us sustain our programs. And then lastly, just a heads up, once we wrap up this webinar, there will be a little evaluation, and we'd appreciate it if you could complete that, because it really helps us improve our programs for the future. So for today, I will wrap up and hope to see you 2 weeks from now so that you can join us for another great discussion. Thank you so much.